Lesson 0.7, logarithms. Logarithms are inverses of exponential. So easiest way to see an inverse, you take the original, and then you have the diagonal y equals x line, and then you reflect across that diagonal line. That's the inverse. So this is the basic graph of our logarithms. Just like exponentials, they have a lot of things in common. So here's that list. So first, the domain is 0 to infinity. So if I look at this yellow one, the domain is all the positive x's. The range is all the y values, going to hit all of them. Notice that's flipped from exponentials. This time, instead of the x-axis being an asymptote, the y-axis is an asymptote on this yellow one. It is still continuous. It is still increasing, but now it's concave down, and it is still 1 to 1. The y-intercept has turned into an x-intercept, and your key point, instead of 1, a, has flipped to a, 1. So that's what all the logarithm graphs have in common. So now that we know that, let's look at graphing this. So first off, whenever you see ln of x, that is log base e of x. E occurs a lot in nature, so they shorten log base e to ln for the natural log. That's where that comes from. So anytime you see ln, it's just a logarithm base e. Anytime you don't see a base on your logarithm, assume that it's base 10. Kind of like whenever you see a square root, you assume there's a 2 there, even though it's not written. With logarithms, it's a 10. So we're going to use a calculator, graph both of these, look at those similarities, and copy them. So y equals, clear these ones. And I'm going to ln of x, my first one, ln, you have a button ln right down there. And then log of x, we don't need to do base 10 because if we don't put anything in there, the calculator assumes that it's base 10. Excuse me. Let's check our window. Looks like -1 to 10 for x. -1 to 10. And y's are -5 to 3. 5 to 3. Graph. So that first one was ln of x, or log base e, and the second was log of x, or log base 10 of x. So notice, the higher the base, the squishier it gets. But they all go through that x-intercept and have that asymptote. So I have my asymptote here. I have that x-intercept. ln of x was higher up, and log of x was squishier. Now let's sketch this using our transformation. So the first one, we have a -2 on the inside, which means I'm going to move left to right, and it's going to be opposite. So that means I am going to move right 2, and that includes your asymptote. So I move my asymptote right 2, my points right 2. It's going to look like that. Except, I'm going to do that dotted because we're not done yet. We also have our absolute value on the outside. So that means I'm going to take all the bottom points and reflect them up. So I'm going to take these bottom points and reflect them up. So my final graph looks like that. Okay, in the next video, we're going to talk about changing logarithmic form into exponential form and vice versa.